blah, blah, blah. All right. So you're gonna have a test on Friday if all goes to plan. Otherwise, we'll see. But today we're talking about absolute value inequalities. You want to make sure you've turned in 3.1 through 3.3. 3.1 and 3.2 are in the grade book. You can see it on your little grade sheet, as well as the quiz. If you need to retake the quiz, I'll give that to you after these notes to fix. You can always check skyward, right? Now, do y'all remember that absolute value functions are like this? Y equals A, X minus H is a liar, plus K. So remember, A tells you if it's flipped or vertically compressed or stretched. This is left and right, H, and then K is up or down. No. Oh, no shave November. Oh, dang. But you know what? Y'all are going to miss the end of it, you know?
Because you won't be here.
Yeah. I'll just have to, like, post pictures every day on the Google Classroom.
Oh, you should. What's your cake? I want to see your cake.
Oh, yeah. And I'll put a little beard on him, too, you know? Baby beard.
Did you see this page? Maybe she posted on Instagram.
Oh, they sent it to the teachers, I saw.
It's so cute.
Yeah. Wait, did everyone get their little grade sheet? Hold on. Let's check this. Hey, everyone. So it says it's been reflected across the x. What's going to be in the equation if it reflects across the x? Negative. The negative in front of A, the negative in front of the bars, flips it across the x-axis. So go ahead and put y equals negative. Then it says vertically compressed by 1/3. So what do I write next? 1/3, because it's less than 1. That's going to vertically compress it. So negative 1/3. Now come the bars. Go ahead and give yourself some room here. Space them out. Make those straight. Yes, X, and then remember, insiders lie. This thing is a dirty liar on the inside with an X. All right, so if it says it's moved left 5, what do I write? Plus 5, because we know it's lying. And then down 6 is going to be what? Minus 6. That's a good one right there. Let me pass out these notes. So we did absolute value equations for 3.3. Sorry I wasn't here, but y'all turned that in hopefully. 3.4 is what we're doing today, which is absolute value inequalities.
Why'd you give me your November?
Baby.
I thought you were even remembering more.
Right. Well, take me to take care of your baby. Well, I am.
Really?
All right.
It's not. After that conversation.
All right, here we go. Ready? Ready? All right, so this says, now, look, this part you got to look at. Would you look at it? Can everyone really look? Really look. I need everyone's head up, please. Please. Now, this is not on your notes, so again, just look at it. This is a reminder of last week, okay? When we have an equal sign, we split it into two. X equals positive 5, and then X equals negative 5. Does that sound familiar from last week?
Yes.
Okay, so again, like I'm doing the splits. X equals 5, X equals negative 5. So that means you're going to have one dot or point at negative 5, 1 point at positive 5, and that's it. So don't have to write this down. This is just like, remember this, okay? I did. Check the recording. All right, here we go. Here's today. Instead of an equal sign, does everyone see we have a less than sign?
Yeah.
So this is where you like shade it. Instead of just one dot, it's like shaded one way or the other. Now here's the trick with this. When you split it, okay, there's some rules to it. And the rules are on the left side of your notes, which we'll get to in a second. But this means the distance is less than 5 units from 0 on the number line. So think about it. X is going to be less than 5 And then if you flip that over, it's going to be also greater than negative 5. Basically, it's going to look like this. Between 5 and negative 5. Okay? Including the 0, though. Okay? All right, does everyone see how that works? So I want you to notice the inequality. So x less than 5, that's normal. Notice the two changes. I changed the inequality from less than to greater than, and the positive 5 to negative 5. So I'm gonna repeat that in a minute. But there's two changes for the second one, okay? Now check this out. What if it's the other way around? Absolute value of x is greater than 5. So check it out. When you split it, okay, it's gonna look like this. Do you see how now instead of going towards each other and connecting, they're going away from each other with a big old gap in the middle, okay? So those are the two possibilities today when you're shading these. And I'll add on to that, there is also, if you look at this little table, there's something called no solution, where nothing on the graph is shaded, and there's also something called infinite solutions, where the entire graph is shaded forever, okay? So look on the left side here. This is on your notes on the left-hand column. It says, step 1, isolate the absolute value bars. We did this last week. You get the bars by themselves. You get rid of the loner, you get rid of the coefficient, you get the bars by themselves, okay? Step 2, determine the solutions. Now, is everyone looking at me? Look in the white of my eyes right here, okay? Let's remember this from last week. I'll be impressed if you know this, okay? If my bars, let's say, equal a positive number, how many solutions are there? 2 solutions. Positive number is 2, okay? If my bars equal a 0, how many solutions is that? 1, okay? But if my bars equal a negative, no solution, okay? So similarly, now no more equals. Let's talk about inequality. Look at the bottom row of this table here. If it's less than a negative, that means no solution. Less than or equal to, no solution. But do you see this like bottom right section right here? Okay. If it's greater than a negative or greater than or equal to a negative, that's when you have infinitely many solutions. We're going to get an example of that today so you can see how that works. But first things first, step 1, isolate the value bar. Step 2, determine the solutions. Use this little table to help you. Step 3 are the 2 things I told you. One of them doesn't change, but the other one changes the inequality sign. Okay, it flips it, and then it negates the sign. The positive, negative sign changes. Okay. Then you solve for x for both of your inequalities, and then you graph it on the number line. So without further ado, let's try this together. Is everyone still focused in here? Let's do example number 1. Okay. By the way, I don't know why this stuff is in the notes because it's not on your notes, so I'm just going to be a hater and exit out. One of those teacher group projects, you know what I'm saying? Why did
you give me so much high expectations for today?
All right, because I'm wearing such a great jersey.
No, I thought we were gonna.
Wait, didn't the Yankees get eliminated?
You know what? So you can
We're not even eliminated. Okay, all right. And like Texas team, New York. All right.
All our players are there.
Wow. All right. Well, let's do this. Ready? Is everyone listening? Step 1, I need to get those bars by themselves. So what do I need to get rid of first? The 5 or the -3? The loner, -3. How do I get rid of a -3? Okay, so +3 on both sides. Cancels out on the left. This is a squeaky chair. Aha.
That is just back to the you know.
That's cool. Slightly less squeaky chair. All right, here we go. Next one. Now, what do I do next? So 12 plus 3 is 15. Next step. What do I need to get rid of next? The 5 coefficients got to go. So we get rid of it by dividing because a coefficient is multiplying. The opposite is to divide. 15 divided by 5 gives me 3. Okay. Now, are my bars by themselves on the left side? Okay. Now we have to think, what are the solutions? Before I solve them, how many solutions would it be? So if it's positive, there are 2, I'll call them endpoints, okay? It's not really 2 solutions unless it's an equal, but this is an inequality. So there's 2 points that we're gonna figure out. So there are 2. If you go back to that little table, let me back it up a little bit, a lot of bit. There we go. Okay, so the situation we got ourselves into, it was less than a positive number, which is going to be what? This one? Open circles shaded in between. So do you see how I can use this to help me? Okay, so let me fast forward a lot. Through the junk we don't need. And here we go. Now, check it out. I need to split this into 2. Then what did it say? There's no equal sign. Wow. X plus 4 is less than 3. So you're gonna just rewrite this the normal way. Okay, so split it into 2. Normal way. But there's 2 changes. Is everyone seeing this? Look, this less than becomes a greater than, and then this positive becomes a negative. There's 2 changes. Yeah, the less than, sorry, the absolute value signs disappear. So one's regular, and then one has 2 changes. Okay. Let me say that one more time, especially if your head's down. I need you looking over here, please. So look, x plus 4 less than 3, exactly the same way, get rid of the bars. But on the other side, less than becomes greater, positive becomes negative. You have to do those 2 changes or it will not work. Okay, so let's solve this. How do I get rid of the plus 4? On both of them, you subtract 4. Minus 4, minus 4. And I'm going to get my, so the left one, 3 minus 4 is -1, yes. And on the right one, -3 minus 4 is -7, yes. So notice the inequalities though. It's x less than -1 and then x greater than -7. So once you have your 2 inequalities, they're either shading towards each other or they're shading away from each other. And again, this little table will help you figure that out, but we can also just use our brains. So everybody, on this number line, I need to put -7 further on the left, -1 further on the right. So you can literally do it just like this. Boop. As long as -7 is on the left, -1 is on the right, because -7 is more negative, it's smaller. Okay. Now we can do this just by thinking. Think about it. If x is less than -1, do we put a shaded circle or an open circle at -1? So the inequality is not underlined, so it's open. Did y'all know that? Not underlined is open, underlined is shaded, right? So go ahead and put an open circle at -1, and then the other one, -7, is also an open circle, right? And then, so this is what I'm thinking. Whoops. Now, if it's less than -1, which way is less than? Left or right? less, left, and it points to the left, okay? So less than -1's going this way, like you can shade it a little bit, but if stop right there just because I don't know about that, you know? On the other one, it says x is greater than -7. Which way is greater? To the right. Greater numbers go to the right. So from -7, we're going to the right, not up. So basically, it's between these two numbers, open circles. Okay, this is the way they did it. Theirs looks a little nicer than mine. Okay, so do you see how that is? You can use the table to help you, or you can just think about it. Which way is less? Which way is greater? Do I underline it? Do I shade it in or not? Okay. No. So is everyone ready for example 2? Ready or not? Example 2. Now I think these. Yeah, they're not. I have to solve these. Here we go. We can do it. Thank you. Now, example 2. What do I need to get rid of first on the left-hand side? Okay, the loner is 10. How do I get rid of a positive 10? -10, -10. The 10s cancel, so I'm going to bring down absolute value of x plus 5 greater than, what's 2 minus 10? Which one? 2 minus 10 is -8. Hold up. What do you notice about this? There's a -8. What does that mean? It could be no solution, or it could be infinitely many solutions. So look at your little table, right? The bottom row tells you if it's a less than sign, it's no solution. If it's a greater than sign, it's infinitely many solutions. So what do y'all think this is? Okay, if this is greater, this is a greater than sign, your table says it's going to be infinite solutions. Or another way, what's the even less amount of writing you could write? What's the sign for infinitely many solutions? Like all of the numbers, like all of the real numbers. Hey, all real numbers.
ARM.
Oh. Oh.
I had it for 3 years. I've never seen it do that.
I had it for 7.
Then no, we either graduated already.
So now we need to, how do you shade all real numbers? Like this. Except not as ugly, okay? Literally, it's all the real numbers, so you can, now if I were you, I'd shade it, and then also shade some arrowheads, like it keeps going forever this way, and it keeps going forever this way. All the real numbers. What? Can we get through these or no? How about example 3 and 4, and then you can go during 5. Wait a minute. All right, example 3. What do I need to get rid of first? -2 is on the side, on the left side. It's a coefficient, so I do need to get rid of it by dividing because it's being multiplied. So divide by -2 on both sides. They cancel, so I get absolute value x minus 1. Hey, get off the phone though. Hey, hey, hey. Put the Pokemon away. All right, what's 10 divided by -2? -5. Oh, I see a negative, so it's a special case. So I less than on my little table tells me it's no solution. Now, how do I put that on the number line? That's it. It's not on the number line. So no solution, not on the number line, no shade, no dots. Don't even think about putting a speck of lead on that line. All right. One more example. We'll do 4, and then I'm gonna let you try 5. Right? Everyone with me? So example 4. Here we go. What do I do first? Minus 2 minus 2. Absolute value of x minus 3. Greater than or equal to. What's 5 minus 2? 3. Okay. It's a positive number, so it's going to be something kind of normal. So we can split this thing. So on the left. Well, hold on. What do I write on the left? What's my first case? What do I write? X minus 3. So you just drop the bars, like my mixtape. All right, so you do that. Then, what are the 2 changes happen on the other one? So the inequality must flip, and the sign must change. Okay, so I'm going to still write x minus 3, but instead of greater than or equal, what am I going to write? Keeps the line. So greater than or equal becomes less than or equal. Positive 3 becomes negative 3. I'm going to draw these arrows. This must change, and this must change. Me looking at you changing.
I know, it's annoying.
Thank you for saying half the wrong answers and laughing at all my jokes on your 8th year of being with me. I remember when you were this tall. Okay. All right, now let's solve these. What do I do first? Get rid of the minus 3s by adding 3 to both sides. Okay, x is greater than 3 plus 3, 6. And then x is less than or equal to negative 3 plus 3, 0. Yeah, the left one, Adam, you get 6. The one on the right, they're opposites, they cancel out. Now, if you have 6 and 0, here's something you don't want to do. Okay, don't put 6 on the left and 0 on the right. Okay, they need to be in numerical order. Okay, so 0 would be on the left. Right, we don't need that. We just need a 0 and a 6 to do this. Okay, now both of these inequalities are underlined. So what kind of circles are those? Shaded or not? Shaded. So go ahead and shade some circles on these points. And the question is, which way do you go? Between or away? Let's think about it. For the 6, it says it's greater than. So which way is that going to go? Left or right? To the right. Okay, so go to the right, put a little arrowhead. That's going forever that way. And then x is less than or equal to 0. Which way is that going? To the left. To the left. To the left. And then you do the Cupid shuffle. So this one's the one with a gap in the middle. Okay. Like Michael Strahan. So I want you to try example 5 on your own, and we'll go over the answers here in a minute.